Hi guys, welcome back. I'm Dr. Alaband, and I'm going to be doing demonstrating a lab for you in your Chem 1806 labs. And Dr. Hathcock again is running the, well, she's the director again. But for this one, I'm going to be determining the determination of acetic acid concentration in vinegar using titration. Okay. So we all, well, most of us, or some of you have gotten used to vinegar, and you know that very foul-smelling odor that comes out of it. Well, that odor is due to acetic acid. Okay. So there is a known amount in there, and so what we're going to be looking for is what the concentration or what molarity value this is. Okay. All right, so now that I got my page I'm ready for, walk you through some of the stuff that you're going to need. You're going to need your bottle of vinegar. You need your 25 milliliter Erlenmeyer flask. You need a bottle of phenolphthalein. That's an acid-base indicator. Just because I had them available to me. You do need a 10 milliliter graduated cylinder. You need your balance. Somewhere in your kit you should have small medicine cups, but again, availability to me, I had a bigger cup. Your 1 molar sodium hydroxide, and you also need your syringe. You know, I did a little bit of work ahead of time to work through this, but you're going to be using some pH equations. So you want to make sure that you know what your pH about, how to calculate that, and that's taking the negative log of your hydrogen ion concentration, or you will often see are often written as negative log of hydronium concentration. Those two equations are the same. Now, one thing I do want to point out to you, just in the way that this is written, if you know the pH of an equation, sorry, getting a little foggy here. If you know the pH of an equation, you can solve for the hydronium concentration. And just to make this a little easier to see, I'm going to go ahead and write this out. Okay. So to solve for pH, it's the negative log of the hydrogen ion concentration. But if I know pH and I want to solve for that hydrogen ion concentration, I would take the inverse of that pH, which actually ends up being 10 to the negative pH. So that negative pH is an exponent. Okay. So when you're looking at this equation right here where it says H plus, those brackets represent that you're looking at concentration. So these brackets mean that we are looking at molarity. Then it says inverse log. Well, that just means 10 to the negative pH. Okay, so that just helps make this calculation a little bit easier. So calculating pH is really going to focus on those two equations. And so what I'm going to be doing is known as a titration method. So I'm going to be adding some base to vinegar, and I know how much sample I have here, but I want to know exactly how much acid is present. Okay. So I know my concentration of base. I know what the volume of base I will be adding because I'm going to be measuring it through here. And so what I'm going to be looking for is specifically when this solution turns color. Okay. When that happens, that will be the equivalence point. An equivalence point means that you have equal moles of acid and equal moles of base. And that'll be also the endpoint of titration. Okay. And again, the endpoint of titration signaling when the equivalence point has been met is when I see a color change. Okay. Now, by this point, hopefully you've had some discussion into what an acid dissociation constant is and how that reflects the strength of an acid or even the strength of a base. Okay. So the higher the Ka value, the stronger the acid or base is going to be. Okay. Now, one of the big advantages to my background of looking at an organic chemist point of view is organic chemistry focused a lot on the values of pKa. And so pKa is the negative log of Ka. Okay. Now, the higher the value the Ka is, the stronger the acid. Okay. If you take the negative log of that Ka value, you will have pKa. Okay. pKa is different. The smaller the value is, the stronger that acid. Okay. So hydrochloric acid, sulfuric acid, those are all strong acids because they have a very, very, very large Ka. Well, if I take the negative log of those values, I'm going to be looking at pKa's in the negatives. Okay. So pKa of hydrochloric acid is about -7. That is a very, very strong acid. Whereas looking at the pKa of water is about 16. And then I could look at some higher ones. So the larger that pKa gets, the weaker the acid is. Okay. Yeah, just for a standpoint view, or how I view, because of my background, I prefer Ka or pKa's. Okay. It's a whole number. I'm looking at 10.9, maybe 11. I'm not looking at scientific notation. So to me, looking at pKa's and determining the strength of an acid or base is a little bit easier. Okay. But again, higher the value for Ka, the stronger the acid's going to be. All right, so in order to get this lab started so that we can actually put some of those terms into practice, I did a little bit of work ahead of time. You need to measure out. You need to put a 10 milliliter graduated cylinder on your balance. And once you put the graduated cylinder on the balance, go ahead and tare that to 0. You will need a pipette. That was not listed in the materials section, but it will make transferring the vinegar to your graduated cylinder much easier. 5 milliliters of vinegar to the graduated cylinder, and make sure that you get the exact mass. And you are going to record that on data table 2. Oops. Actually, sorry, data table 1. Data table 2 is for your vinegar sample of your choosing. So I'm going to go ahead and put this on data table 1. There we go. Okay. So you're going to have to pick a vinegar of your choice. If you've got some, let's see.
Balsamic vinegar.
Yeah, balsamic vinegar.
Red wine vinegar.
Yeah. See, all these vinegars come to choice. They're just, red wine sounded good. But your choice. If you have something at home, use that. So 5 milliliters in here, into your graduated cylinder. Make sure that you get the accurate measurement. You need the exact mass. Put it on data table 1. Once you have measured your mass, go ahead and transfer it to your Erlenmeyer flask, which I have done. Then, make sure that, because you're going to need to get 10 milliliters of 1 molar sodium hydroxide, make sure that you rinse this out very, very, very thoroughly. And so I would recommend at least 3 times that you wash this, because if I put sodium hydroxide into here, that's going to change the concentration of your base. So make sure that you rinse this thoroughly with water before you actually move to measure your sodium hydroxide. All right, so you're going to need to measure out 10 milliliters of 1 molar sodium hydroxide. Once you have measured out 10 milliliters, you're going to transfer it to this cup. All right, before I move on to dealing with sodium hydroxide, you're going to need to take your phenolphthalein indicator. This is your acid base indicator, so at certain pHs it will change colors. So I'm just going to add a couple drops. It doesn't take a lot, but this is what's going to signify the end of the reaction. So there are a lot of different indicators that you have available. And you can do some household ones if you're interested in looking at that. Cabbage juice, grape juice is some ones that if you want to play around with or explore the topic, you can. But each one's going to behave differently in a different environment. So this is acidic, and you notice that phenolphthalein is clear in color. Now, you're going to want to take your syringe and put it into the cup. And you want to minimize as much air as you can. Okay. So I'm going to put the tip of the syringe into the sodium hydroxide, and I'm going to pull up. Okay. If you get an air bubble, go ahead and push it back down, and that should dislodge the air bubble, and pull that back up, and you should see that air bubble disappear. If you need to do that a couple of times, you can do that a couple of times. Okay.
You can also flip the syringe over.
Yeah. And flipping of the syringe is a common technique because if you can see I'll just do it now. You can see that I do have an air bubble since I've gone ahead and pulled this up. So just for demonstrations, you can see as I'm pulling up, it's not in any liquid, so I'm just pulling air. Okay. You can also, and this is a good way to just dispose or dislodge any remaining air, tip it upside down. Okay. And just go ahead and have your cup next to you just in case. Because I had a little bit of, let's see. There we go, a little air bubble there. Give it just a little squirt. Okay. And it should, if you look carefully, you can minimize all of your potential air bubbles, so it should be no air present. All right, so next thing that we're going to need to do, okay, is record the initial volume of the syringe. Sorry guys, it's starting to get a little fuzzy in here. Okay. So your initial volume is where is that plunger sitting at initially. Okay. Remember, this is a 10 milliliter syringe. Okay. You want to read where that plunger is. So what volume marking does it occur at? And after dislodging the air, you may not be right at 10. Okay, I got it. Okay, so looks like I'm sitting right at that 9 milliliter line. Okay. So I've lost about 1 milliliter, and so that'd be account for what that volume right there is. Okay. All right, so my initial volume, I'm going to go on to data table 1, and I'm going to fill in the 9 milliliter line. Okay. All right, so now comes the part that we actually do the titration on. All right, so if you look at step number 11, it says to add 0.5 milliliter increments. Okay, so I'm at 9 milliliters now. I need to end at 8.5. Then I'm going to end at 8, and I'm going to end at 7.5 and 7. Okay. You should not need all the complete 10 milliliters. Okay. But we're going to add sodium hydroxide in 0.5 milliliter increments, okay, until a single drop causes this color to change from clear to pink, and that persists for a few seconds. All right, so I'm going to try and, you may want to have your volume line pointed to you. And ideally, what you want is a faint pink color. So that's why they suggest putting this under a piece of paper, because if it is a dark pink color, then you've gone a little too far. All right, so I'm going to try and get this to 8.5. And you can already see there's that pink color. So if I didn't see that pink color, then I could add it quicker. But since I'm seeing that pink color, I need to add this fairly slowly. And you want to swirl this as you're adding. Almost there. Oops. I'm getting close. You can see that pink color is lasting longer. It's not. Okay. Now that color is going to stick around for a while. So it is a little hard to, push so much in. All right, now you're going to read again the bottom of your plunger and note what your volume level is. And make sure that you do read these correctly. So I went ahead and, there we go. Let you guys kind of figure that part of it out. Okay, just to make sure, I'm going to go ahead and pull this up a little bit. That line right there, that line, that's your 0 milliliter line. That means there's no more base to be added. At this line right here, let's see, so if you're up here, that's your 10 milliliter line. So there you've added 1 milliliter, and you've added a second one because remember we're pushing down. So in here, that line would tell you how many milliliters are present in the syringe. Okay. So I ended up somewhere down in this area, and so let's say mine ended at 5. So the initial volume for mine was, before I started dispensing any sodium hydroxide, the initial volume read 9 milliliters. Okay. Then it ended at 5 milliliters. Okay. So the difference between those two would tell you exactly how many milliliters of base you have added. Okay. So if I started at 9, it ended at 5. That means I've added 4 milliliters of base, and that there would be another initial 5 milliliters of base remaining in the syringe. Okay. So your initial volume is before you added any sodium hydroxide. Where did that plunger start at? What volume reading? Then you're going to add sodium hydroxide in 0.5 milliliter increments until this turns pink and stays pink. Okay. Once you have reached that color, you're going to record the volume of base. What volume marking did it stop on? And then the difference between those two will tell you how much base you've added. Okay. Your final volume should be lower than your initial. Okay. And then the difference will be your total volume. Okay. You know volume of base added. You know the concentration of the base that was added. So knowing that molarity is moles per liter, you could calculate how many moles of sodium hydroxide was added. Okay. So if you know that how many moles of sodium hydroxide was added, you also know how many moles of acetic acid was given. Because what you're going to want to look at is look at page 4 and you look at the equation. So now if I look at this, I see that it is balanced. So for every mole of sodium hydroxide, there's going to be the same number of moles of acetic acid that was needed. Okay? So I made use of that balanced equation. So if I know the moles of acetic acid, I can find molar mass of acetic acid, and then I can determine the number of grams, and then therefore I can also calculate the molarity of the acid. Okay. Now, just to make sure on the molarity of the acid, 25 milliliters of acid was added. Okay, so your volume of acetic acid for that calculation will be 25 milliliters. Okay. Going through the calculations on the table, you determine the number of moles, and then you can calculate the percent of acetic acid. Okay. So once you have done all of that calculations, and they walk you through those, okay, so that was just a quick summary of what you're going to do. You're going to pick an acid of your choice, okay, a vinegar sample of your choice, repeat it all again, and that will conclude activity 1. Okay. And then activity 2, there's not an experiment to be done. You just have to complete the missing information on this table. They give you some of it, but in order to calculate these missing blanks, you need to make use of these equations. So this part here, just make sure you understand what you've gone through in this part before. All right, and if you have any questions, there is some resources here you can look at how to do titration calculations and how to set up, but hopefully we have covered most of that to make it a little easier. But if you need help, just let me know. But good luck with this experiment.